Okay, so now I am so excited to introduce this next dynamic woman. She is the CEO of the company Hydroplane, and this company was founded by the former NASA engineer, Dr. Anita Sengupta, and it is a minority woman-based woman-owned small business focusing on eliminating aviation carbon emissions. She is an aerospace engineer, a rocket scientist, aerospace executive, and instrument rated pilot who has developed technologies that have enabled the exploration of Mars, asteroids, and deep space for 22 years. I would like to introduce Dr. Anita Sengupta.
Hello, thank you so much for having me. I'm happy to be here.
Oh, thank you so much for being here. We're so excited to learn more about you from your point of view. So before we go into learning more about Hydroplane, I'd like to ask a few questions about you. Tell me a little bit about your upbringing. I mean, what was your household like? Was it all scientists?
Well, so my dad was a PhD trained mechanical engineer, a huge science fiction fan himself. So my dad and I used to watch reruns of Star Trek when I was a little kid. So I grew up basically loving science fiction. I was also born in the UK. So every summer we would fly back and forth between New York, where I grew up for the most part, and the UK in a Boeing 747. So aviation has been part of my life with very large aircraft ever since I was a little kid. So huge science fiction fan, huge space program fan, and huge aviation fan.
Wow. Okay. And so how did you even think that hydrogen cell was going to have to come into, like, there needed to be more cleaner, sustainable aviation? How did that even come to play?
Well, so my primary hobby actually is flying small planes. And so during the pandemic, I actually got my commercial rating too. So I had to update my bio on that front. But so I love to fly small aircraft, but I also really care about climate change. And the reason why I left my career at NASA is that I wanted to do something to address climate change. So I left about 5 years ago to join the green transportation sector, first as an executive at a Hyperloop technology company, then working on battery powered aircraft. And whilst I was designing battery powered aircraft for the urban air mobility eVTOL space, I realized that batteries were not a good evolutionary solution for the majority of aviation use cases, which is the reason why I founded Hydroplane to develop hydrogen fuel cell technology, which can address the endurance which is required for aviation.
But is there a competition? Because from what I've researched, I know that there is ground studies on battery operated cars and hydrogen fuel cell cars. Is that the same in aviation? Is there a competition with that?
So you can have a battery operated plane, but it's only going to be able to fly for about 1 hour. So there's only a small number of aviation use cases that addresses. So something like a air taxi that goes from one part in a city to another part in a city, or maybe a flight training plane could be battery powered. But if you want to go to regional travel, anything beyond basically an hour, you need to shift to something which has a better energy density, which is more energy per unit mass. And that's where hydrogen fuel cell technology comes in. And that's where hydrogen fuel comes in.
So that affects the weight of the plane then. And so you're able to carry more weight, more passengers. Is that the idea behind that then?
Yeah, so with hydrogen fuel cell technology, you can get to the same useful load or even better than what you have with 100 LL and Jet A. Whereas with batteries, you can't achieve the same useful load as you would with 100 LL or Jet A.
But why are they even still making battery then? If that's the case, it sounds like it's not even worth it.
Well, it's okay for short range applications. So where the emphasis has been is in urban air mobility, where you're flying from one place in the city to another place in the city, so that you could do like a 15-minute flight 4 times within an hour. But ultimately, for aviation, we usually fly because we want to go places over long distances quickly. That's where you need larger platforms, a better useful load, and then an energy source which is more has a better specific power and a specific energy.
So is that the air taxi that you were talking about, just going from here to there? I mean, are you talking about flying cars and flying like small planes? Are you talking about that?
Yeah, so there is definitely a huge movement afoot in the eVTOL space, electric vertical takeoff and landing, which can be done with batteries because it's going over short distances by definition. But when you want to shift to longer travel, such as regional travel, going from one city to another city, or eventually across the country, or even transatlantic, transoceanic, transpacific, then you would need to shift to something which has more better energy density.
So does that mean Southwest Airlines may be looking at you or Delta may be looking at you? Is that what you're saying?
Well, so that is the ultimate goal for the company, is to work on regional travel, so twin turboprop aircraft. But right now, I think a better way to get this product into market is to start with smaller aircraft, which is what we're doing. So single engine aircraft, which are used for air taxis, which are used for flight training, which can be used for regional travel, from LA to San Francisco, for example. And so starting with a smaller aircraft, it's easier to get the thing certified initially, and then you can work your way up to larger and larger platforms. And that's something I actually learned from my space program expertise, is you solve a challenging problem at a certain scale, you make that work, and then you grow it to larger scales.
Okay, so for those of us who are very new to hydrogen fuel cells, and how that works, please tell us what that is. Is that gas? Is that oil? Please tell us everything and where it fits.
Yeah, so for sure. So you can think of a hydrogen fuel cell as a hydrogen ion battery versus the lithium ion battery they're used to. So what happens is you have hydrogen, which is brought into the fuel cell as a gas. The hydrogen gas is an H2 molecule. That H2 molecule is then split up into hydrogen ions and electrons. The electrons that are released actually is your electricity. They flow in a circuit to create electricity for the fuel cell. And the hydrogen ions then pass through a membrane, which is called a polymer electrolyte membrane. It actually kind of looks like a piece of saran wrap. Those hydrogen ions then combine with oxygen ions, which come from the air that you also have to disassociate with another process to form water. So the only output of that reaction is actually water. So the reason why we call the company Hydroplane is because it is a plane that emits water.
Wow. Okay. So what kind of subjects would our younger students have to, I mean, obviously chemistry, but is there anything else that they would have to major in to really understand and grasp what you just described?
So there are many different areas of the STEM fields that you could focus on as a means of being part of the alternative renewable energy space. So all of my degrees are in aerospace engineering. I got my bachelor's, master's, and PhD in aerospace engineering, and my PhD was actually in electric propulsion for spacecraft. So using hydrogen fuel cell technology or using battery technology coupled to an electric motor is something called electric propulsion. And that electric propulsion can be used to propel vehicles on the ground. It can also be used to propel aircraft. It can also be used to propel spacecraft in a slightly different way. So ultimately, you can study aerospace engineering, mechanical engineering, electrical engineering, chemical engineering, chemistry. There's so many different fields that you could potentially study. And you can also be a computer scientist and a software engineer as well.
Wow. Okay. So I have to ask you though, as a minority and as a female, okay, because that's why we're here. Tell me what that has been like for you in this field. Have you felt like you noticed you were a woman and a minority, or is it just I'm a scientist, you're a scientist, and we're just moving ahead?
So it is sad to say that, even after all my years in the field, 2 decades worth, that there's still not enough women engineers, and there's still not enough, minority engineers. So I think that is still a problem. And one of the reasons why I like to do these podcasts is to put a face out there, which is like, you look like me, you can be like me, also study the engineering fields. I'm also a professor at the University of Southern California. And there, even so, at least my class is usually somewhere between 20 to 30% women, but still it's not enough. We want to get it up to 50%. So yes, unfortunately, you do feel it when you're the only woman in the room. And there's been many projects where I've been the only woman in the room, or in some cases, the only woman in a huge section of a company. So it's something that we have to make a concerted effort to get more young people, more young women, more underrepresented groups interested in at a very young age, so that they go in and do their degrees in it, and then they take places in the workforce, and then ultimately go into leadership roles like I have now, so then we can form a company which has diversity.
So, but with that though, being the only female, I mean, have you made to feel like you were the only female? Have you seen that there were maybe setbacks because you were the only female? Something like that.
Well, I mean, one of the annoying things is that there may not always be a bathroom. Present, you have to like travel several floors or go to a different building or something like that, or the bathroom isn't as clean as you'd like it to be. So there's certainly been sort of like logistical challenges on that front. And same thing in the aviation community, right? There's not a lot of women pilots. And so you certainly feel it's slightly different. But I've been in this space my whole career, so I've kind of gotten used to it in that sense. And most of my friends are actually men, or I'm friends with the wives of my male friends. So it's just kind of like that's the system that it is. But I guess it never bothered me because my dad was an engineer, and I gravitated towards the subject matter so much that I was just like a laser focused on wanting to do this. And I've had a lot of really good role models actually in the scientific world, right? We have Dr. Beverly Crusher, Belana Torres, chief engineer, Dax, chief science officer in Star Trek. So there are many great role models that you can pull from, but it is kind of sad that I'm referring to role models from science fiction because just in the workplace environment, there's not enough. And so now I like to pay it forward. So I try and mentor as many young women as I can as part of mentorship programs in the aerospace community. And that's something that we can do to help there be more women at a younger age coming in.
So I see that beautiful plane behind you. That is the Piper that you experiment on. Am I correct?
Yes.
Okay. Do you have a name for that Piper? Because I know that one is very special.
So we have two names. One for it is the engineering name, which is protium. And so protium is one of the isotopes of hydrogen. So I figured it'd be a fun play on words to say protium. But we also have another name, which will probably be part of our PR, which is when I was flying this aircraft over from Tyler, Texas, which is in southeast Dallas back in last year. And I was flying it all the way from there to Los Angeles. Took several days, flying at Piper speeds. And I was getting pretty tired on the final leg of the journey where I think I was like somewhere over Palm Springs, and the air traffic controller asked me something, then I responded, and the aircraft's tail number is 8023 whiskey, but I responded 8023 whiskers, and then I left, and I think the controller left as well. And I'm a cat person. I love cats. I have two cats. So we're also going to have another name for it, which is going to be the Model M, the Muad'Dib, because my cat was sadly, he passed away last year. He was named Muad'Dib, and Muad'Dib also means teacher. So our first aircraft will be named 8023 Whiskers, tail number, with a picture of my cat as the Model M Muad'Dib.
So I do want to ask you, I was reading some more about your plight in getting this certified, getting everything certified with what you're doing. And I saw that you have to go through a pretty strenuous type of credit airworthiness certification. Are you doing that trying to get a special airworthiness or a standard airworthiness FAA certification?
So our product is a power plant, initially for single engine aircraft, 200 kilowatts, which is 270 horsepower, but ultimately providing more than 200 horsepower to the prop. So that covers a range of platforms from Piper Archer to Piper Arrows to Cessna 172, 182, Cirrus SR20. So what we're doing is a power plant certification for pre-existing airframes, which means that we will need a supplemental type certificate for each airframe that we do. And so it is definitely an engineering challenge. It's a new piece of technology to the FAA, so which means you have to go through a process of showing that the engine, in our case, power plant, meets all of the requirements for safety, reliability, and durability on the ground. But it is a process that any engine manufacturer has to go through. So we'll have to go through that process as well. A little bit more complicated for us because it's with fuel cell technology, which is obviously different from internal combustion engine technology. But the really great part about fuel cell technology, which is fantastic for the aviation operator, pilot, end user, aircraft owner, is that the maintenance costs will likely be lower because it's an electric propulsion system, which means it doesn't have any moving parts. It's operating at relatively low temperature. So it will be easier for you to maintain on your airplane and cost you less.
Well, where would you fuel up though? Where are the stations for you to fuel up?
So one of the big challenges when you do any kind of energy sector transition is that you have to get infrastructure investment. So for the first battery powered cars, the first people who were, the first adopters of that technology, they didn't have as many charging stations they go to. But over time, as there's more users of the technology, there's more infrastructure investment. And now there's pretty much charging stations everywhere, at least if you live in California. I myself have a hydrogen fuel cell car. And so I'm actually able to fuel my car in Southern California, no problem. In Northern California, no problem. So it really isn't that much of a transition to be able to get some fueling stations put at a few key airports to service the Southern California area, as well as connectivity to, let's say, Las Vegas, to San Diego, to Northern California. So it is a process that you have to go through and work with the infrastructure providers, which means working with your local government, local community. But it's a network that we can already tap into in Southern California because we already have fueling stations for cars.
Well, are you working with other companies? I think there's a Boston-based hydrogen fuel cell as well too, correct? Or is it just you that has this market?
So there are several companies that have existed for many years who do hydrogen fuel cell technology for different applications. It can be for ground-based applications, for generating power for buildings and offices and things like that. There's also electrolyzers, which are basically fuel cells in reverse. There are also a few companies who develop fuel cells for car applications, automotive applications, but I believe we're one of the only or very few companies who's developing an aviation specific hydrogen fuel cell stack and power plant, a PEM one.
Wow, congratulations. Okay, so now that you're saying this, then how do you choose your team? I mean, because again, we're here for women. So are you doing it where you're hiring more females? Or are you just looking for who knows the most about chemistry and hydrogen fuel cells?
Well, diversity for me is really important because diversity of thought actually leads to diversity of solutions, which actually leads to better solutions. And if you're developing a product that you're going to sell commercially, your customer base is going to be everybody. So you have to have everybody represented in your team for that reason. And so we do have a very diverse team of people from around the world, people of different ethnicities, and of men and of women. And that's really important to me. And then because I am also a professor and I've been working for many years, I have this great network of former students. So I've already hired on one of my former student interns who worked for me at NASA JPL. She's our head of systems and software. And we also have our cryogenic tank design led by another woman student from Florida. And then we also have our system engineering activity. We have a young woman who is also a former student of mine from Georgia Tech.
So for the students who are watching this, if they want to apply, they just have to contact Hydroplane Company.
So we always do have part-time internships during the year, and then we also have a summer internship program. And so although I probably don't have the updated link on the website now, when we have the internship program open up again, we'll have a link on our website, which is hydroplane.us. And you can also follow us on social media where we'll also advertise when we're going to have things like hiring and things like that. But we had, I think, 8 interns working for us this summer. So that's a lot.
Were they working the booth at the EAA Air Ventures?
Yes, we had 2 of them who supported that at EAA Air Venture as well, but we have several who are actually aviation maintenance technician students. We have several who are automotive technician students as well as engineering students. So we cover the full gamut of what's going to be required to initiate hydrogen aviation from a job career perspective.
So the people, I saw that your tweet when you said, okay, we finished the air ventures and we're back. And the common phrase that people were saying was when can I get one? And wow, this is the future. I think you stunned them because they never comprehend. So the ones who were saying this is the future, what more could they say? Because they're looking at it and they never probably pictured that something like that would be in their lifetime. And so for the ones who said, I want one, when can I get one? My question goes into how I see that you don't have to make the plane. You actually can have it put in their Cessna. Am I correct?
Yes.
So if they already own their plane, they can actually buy your plant, or I think it's power plant. Is that what
power plant? Yeah.
Yes. And they can have their maintenance person install it. Is that what you're saying?
That is the business model. But of course, we do have to go through the STC process so that they can maintain their airworthiness on their Piper and their Cessna, which is what we'll be going through over the course of the next 2 years. But for someone who's an experimental aircraft owner, they could have it, as early as, a year from now.
Oh my gosh. And I'm hoping I'm able to fly in one. I hear that it's really quiet.
Yes, that's one of the great advantages is that because you no longer have a combustion engine generating the noise from the combustion chamber, it'll now sound more equivalent to an electric ground-based car, whether it's battery or fuel cell powered. You will still get the propeller noise, but you'll get significantly less noise in the cockpit, and more importantly, less noise outside, which means less noise pollution for local communities.
So, but you're saying that this will be out as far as experimental, as soon as next year is what you're saying, experimental.
So our first flight demonstration is planned for the first quarter of next year as part of our Agility Prime AFWERX funded activity. And then we have a little bit more progress to make on that, lessons learned from the first flight test program. And then we'll try and get our product out to the experimental aircraft community in, hopefully just a little bit over a year.
Wow. I mean, kudos. You are such an inspirational woman. I mean, I would love to keep up with you and be a part of your team and just watch what you're doing. So, are there any final words that you can tell the watchers, the viewers who are watching you?
So I would say my one important life lesson is that you have to follow your passion. You have to follow your dreams. When I was choosing what degree program to go into, I had a lot of people tell me in the 1990s that, the aerospace sector isn't doing well. You probably should get a degree in mechanical engineering, but I really wanted to be an aerospace engineer. I'm like, I'm going to do it because that's what I want to do. That's what my passion is. So always follow your passion, always follow your dreams. And the other one is take on complicated, interesting challenges, because that's where you're able to be stimulated intellectually. That's the way you can really contribute to society. Don't take the easy way out. Actually do the really difficult things and make them happen.
I do have one more thing. So if someone wanted to do a little bit more research about the hydrogen fuel cells, as far as the students who are watching, would they be able to just look at your company and see a comprehensive demonstration of what the process actually looks like with what you described? Or is this something that they can just YouTube? How can they find more information about that?
Well, that's actually a really good point. So I think we do obviously have a website where we talk about what we're doing as a company. And because we're a small business, we have a lot of proprietary IP, so we can't go into too much details of our specific design. But as we are now out of stealth mode, as I'm out doing communications, I'm going to be doing a lot more talks on the topic. I recently did a TEDx talk over at Edwards Air Force Base, which will be coming out soon, will be available online. And I'm doing different events all the time. So you can actually just Google me and also check out our website to find out our latest media and events. But I could also follow up with actually generating some specific content for school teachers. That's something I should probably look into. And maybe I can do that in part with the 99s.
Dr. Anita, thank you so much for your time. I'm sure everyone learned so much and they are so inspired by you. You are just a ray of light. So I'm just going to end this now. Thank you so much, everyone, for joining us. This is Dr. Anita Sengupta with Hydroplane.